In a world that runs on software, how do you actually make sure it works? I mean, across different teams, different companies, even different countries. Well, there's an answer for that. Today, we're diving deep into ISO 29119, the global playbook for software testing. Let's get right into it.
So, why dedicate a whole international standard just to testing? This number right here, this is a huge part of the answer. For really critical software, think aviation or medical gear, testing can chew up to 80% of the entire project budget. 80%. That is a massive slice of the pie. And when you're spending that kind of cash, you absolutely cannot afford to just make it up as you go. All right, so here's our game plan for today. We're going to start with why we need this in the first place, the high cost of bugs. Then we'll really unpack the ISO 29119 standard itself, digging into its three-level structure and the specific tools and techniques it gives us. We'll even see how it handles modern automation before we pull it all together to see why this really matters to all of us. For a long time, software testing was kind of the Wild West. Seriously, every team had their own way of doing things, the paperwork was all over the place, and the results, often expensive and pretty unreliable. What was really missing was a common language, a professional framework that everyone could just agree on.
So when we say testing, what are we really talking about? It's way more than just trying to break things. The official goal is to find that gap between what the software actually does and what it's supposed to do. It's basically part bug hunt and part quality check, just making sure everything works exactly the way it was designed.
So, to bring some order to all that chaos, the International Organization for Standardization, you know them as ISO, stepped in. They created ISO 29119. The whole idea was to have a single, all-in-one standard to cover every single part of software testing, from the initial planning to the final report, for any project, anywhere. This diagram, this really gets to the heart of how the standard thinks. Right there in the middle, you've got processes. That's the how-to part. To actually do those processes, you use specific techniques. As you do the work, you generate documentation. And the glue holding it all together, that's the concepts and definitions which make sure everyone is speaking the same language. It's a really simple but powerful loop. Okay, but how does the standard organize all this for a real project? Well, it uses a super clear three-level hierarchy. The best way to think about it is like a pyramid of responsibility, starting at the very top of a company and going all the way down to the person actually running the tests.
So here they are. At the very top, you have the organizational test process. Then, in the middle, the test management processes. And at the bottom, doing all the hands-on work, are the dynamic test processes. Now, let's see how they all work together. And this is where it all clicks into place. See how the strategy flows down? The organizational level sets the big picture policy. Test management takes that policy and turns it into actual project plans. And then those plans tell the dynamic teams what to test. But, and this is absolutely crucial, the information flows back up. The results and reports from that hands-on testing provide feedback that makes the whole process better, from the very top. It's a continuous improvement loop. Let's make this even simpler. Just think of a company. The organizational level, that's your corporate HQ. They set the rules for everybody. The management level is like a single department. It takes those big rules and makes a plan for a specific project. And the dynamic level, that's the project team in the trenches, the ones actually doing the work. HQ has the vision, departments manage it, and teams get it done. So we've got the high-level structure down. Now let's zoom in and get our hands dirty. Let's look at the actual nuts and bolts, the real tools and methods the standard gives you to get the job done. Okay, let's make this really concrete. Take just one process: test, monitoring, and control. The standard breaks it down into specific tasks. As you can see here, with TMC2, you monitor. That means collecting data. With TMC3, you control, making sure the plan is being followed. And with TMC4, you report. You tell people how it's going. It's this level of specific, actionable detail that makes the standard so useful. All of these processes create a paper trail, or, a digital one these days. The standard lays out templates for specific documents for every stage. Everything from the high-level test policy you see here, right down to a test incident report for a single tiny bug. The whole point is to standardize the output just as much as the process itself. Now, the standard also covers different ways to test. The two big categories are right here. On one side, you've got black box testing. Think of it like testing a car without ever popping the hood. You only care that it starts, stops, and turns. On the other side is white box testing. Now, the hood is wide open. You can see the engine, the actual code, and you design your tests based on how it's all wired together inside.
But hey, this standard isn't just some old, dusty rulebook. It fully embraces modern stuff like test automation. And a really key part of that is an approach called keyword-driven testing, which is all about making automated tests way simpler and more powerful. So what's so smart about this keyword approach? Well, instead of writing complex code for every single test, you use simple, human-readable words like login or check balance. Each keyword is like a reusable building block of code. This means the tests are easier for everybody to understand, they're way easier to maintain, and in the end, it just makes the whole automation process cheaper and faster. It's a total win-win. So we've covered the structure, the processes, the techniques. Let's zoom all the way back out for the big picture. Why does any of this actually matter in the real world?
When you boil it all down, it comes to this: having a shared framework, a common language. When everyone, from the software developers to the project managers to the clients, is working from the same playbook, the whole process just gets way more efficient. And that efficiency, it translates directly into higher quality software. For businesses, that's less risk. For all of us, it just means stuff that works the way it's supposed to. And that kind of brings us to a final question to chew on. Our world absolutely runs on software. It's in our cars, it's in our banks, it's in our pockets. In a world that is so fundamentally built on code, is having a global standard for quality still just a nice idea, or has it become an absolute necessity?